You see my screen?
Yes.
So
Go ahead.
I can start?
Yes, please.
Yes. So hello everyone. I am Min. I'm a PhD student in computer science from Université at Toulouse, France. I'm very happy to be here to present our work on 3D object detection. The title of the paper is spare LiDAR and stereo fusion for deep estimation and 3D object detection. This work is supervised by Dr. Pierre Duthon, Dr. Louahdi Khoudour, Dr. Alain Crouzil, and Professor Sergio Velastin. So first of all, look at the input and the output of our model. So we want to build a system that give an input like this, which contain left and right color image, and the projection of LiDAR for beam on the left and the right side. And then our model will produce a dense deep map and 3D bounding boxes like this for every object in the scene. So look at the background. So why we are interested in deep estimation? Because with deep depth estimation is very useful for this start like navigation or mapping. It also help to detect the position, the shape, the appearance of the object in imagery. And why we are interested in stereo and LiDAR for beams? Because with stereo, we can get the deep map by using traditional method like finding the point matching between the image or recently using deep learning method. However, it's not accurate enough because the sensor like camera is very affected by light condition. So we need to combine the LiDAR with a very accurate, but instead of using a LiDAR sitting for beams, which cost $75,000, we want to use the LiDAR for beams with a cheaper but still can cover almost objects in the scene. And why we are interested also in 3D object detection? Because with 3D object detection, we can know the type of object. For example, it's a car, or it's a person, or it's nothing. We can also locate the object in the image. The 2D bounding boxes, and we can also detect the distance. For example, between from the ego vehicle to the object in the scene. Previous works for 3D object detection and deep estimation, it had several methods to do this. I list here three types of method depending on the sensor we use. For example, we can use monocular or stereo sensor for 3D object detection and deep estimation tasks. And recently, we can use also the LiDAR sensor. I have a list is here some method to process the LiDAR point cloud. For example, the projection based method, volumetric based method, or point net method, etc. And we can also fuse the LiDAR and camera. I list here three type of fusion. Early fusion, later fusion, and other fusion like diffusion or multifusion. So related to our work, it had a method with name pseudo LiDAR, which present a very interesting idea from a single or stereo camera system. In general, it take image as input and use the and use an deep estimation network to obtain a density map like this for every pixel. And then the idea of the paper is using a very simple converse deep map to pseudo point cloud for every pixel by using calibration. And finally, we can apply any top LiDAR based method uh, on the point cloud to produce um, the 3D bounding boxy for the object in the scene. So the research question is, from there, can we design an architecture to fuse, to create a chip system, fuse stereo and LiDAR 4 beams to achieve a better performance than monocular or stereo methods, and also get a reason close to performance of LiDAR based method. So related to our work, it had also a paper with name pseudo LiDAR plus plus is after pseudo LiDAR method. Um, the author have simulated the LiDAR 4 beams from the LiDAR sitting 4 beams to correct or robust the pseudo point cloud by applying graph-based correction. And what we want to try here is integrating this LiDAR 4 beam in the deep estimation network to produce a better deep map. And then from there we can get a better performance in the 3D object detection task. So look at our method. So inspired by stereo deep network, we have add the LiDAR 4 beams at an additional channel, and with a multi-channel encoder decoder network inspired from deep LiDAR method. We have to extra an a pair of future map from left and right side, and then we can put the future map into a disparity cost volume to create a 40 disparity cost model, and then we can put into a deep code deep depth code volume to create a 80 depth code model, and from this we can directly optimize the depth information. And finally we have a short map, and we can get the depth map like this one. So look at the reasons. So in our experiments we have used the Kitty dataset, um, which have a velocity sensor. It means the LiDAR 64 beams, and also a stereo camera system. Um, for our training, uh, firstly we have to train our deep estimation network. we train our network on firstly on scene flow dataset, and then fine tuning on kitty object detection dataset to obtain the depth map and also the pseudo point cloud. And secondly, for the 3D object detection step, we have uh, used the point cloud point SNN method to um, 3D object detection task and training the point cloud pseudo point cloud on kitty object detection dataset. And now look at the reason on depth estimation. Um, for depth estimation, our method produce a better reason compared to our baseline method, pseudo LiDAR plus on several metric. And now this is the reason on 3D object detection. Firstly, our method on smooth pass the other method, the other monocular and stereo method on several metric. And secondly, when uh, when don't use the graph based correction, our method present a better performance compared to pseudo LiDAR plus. This is show the LiDAR effectiveness in our depth estimation network. And finally, when compared to the LiDAR based method, our method can achieve a closer reason compared to the LiDAR method point SNN. But remember here is the LiDAR based method is very expensive. So here is some visual reason on of our method on kitty dataset. So in summary, we have a proposed an a nouveau architecture by fusing a chip LiDAR and stereo system to predict deep map and 3D object detection, 3D body boxes. We have also shown a quite experimental reasons to to validate our network design on deep estimation and 3D object detection tasks. This is a creator and chip system, and our code will be released in the link you can see here. So let's talk some future work. So maybe we need to design a network to process the then pseudo point cloud, which is the output of our depth estimation network, because the current research on LiDAR based method process LiDAR sitting four beams. Why the dense pseudo point cloud is system denser than LiDAR sitting four beams. And we are also in the process of working on the affection of adverse weather like fog or rain on camera or LiDAR. So that's all I want to introduce today. Thank you very much.
Thank you very much, Nguyen. Are there any questions from the audience? I have a question, Nguyen. Does this work on night conditions or in bad weather conditions?
This is on the night condition, because kitty data set certain it have it's collecting the data in a night condition.
sorry, I didn't understand you. So there is a night collection in Quito?
No, yes, it's collected in night condition.
Okay. So and why is it? You also explained that it was good weather. Does bad weather also affect the?
Yes.
Yes.
For example, for the camera, camera is very affected by the light condition. For example,
Okay.
in the night, where we cannot see the object, or for example, and for the LiDAR sensor, it is very affected by the fog or the rain condition.
Okay. Yeah, rain. Yeah. Okay. Yeah, rain could also affect. Yeah, I thought of fog or something like that. Thank you very much for the good presentation, Nguyen.